Section 5.4 in the polynomial review is going to work more with rules of exponents. Our first rule is the quotient rule. Quotient means dividing. So we're going to have a fraction. If I have a to the m over a to the n equals a to the m minus n, just like with multiplying, the a has to match and stay the same into the answer. Subtract the exponents. Also, we include this statement that a cannot equal 0 because it's the denominator of a fraction. We also have the quotient to a power rule. Quotient to a power rule. If I have a fraction with an exponent on the outside, then I can distribute that exponent. And again, the statement that the denominator is not allowed to equal 0. A couple of more rules. One is the 0 exponent rule. The 0 exponent rule is anything raised to the 0 power is equal to 1, except 0 itself. 0 to the 0 is something entirely different. You would maybe study that in calculus. We also have a negative exponent rule. The negative exponent rule, if I want to make the exponent positive, it's going to move to the other side of the fraction. Or if it starts out negative in the denominator, then it'll move to the numerator and become positive. Also, a cannot equal 0 since it either starts out or could end up in the denominator of a fraction. To simplify some examples, letter A has this z equals 0, cannot equal 0 piece. That's just there to remind you. You don't have to do anything with it. Simplifying the fraction itself, 16 over 12 is 4 over 3. With the z's, I'm going to subtract the exponents to get squared. Letter B, I'm going to distribute 2 to the 4th, m to the 12th, n to the 8th, and then go ahead and solve out. 2 to the 4th power is 16, m to the 12th, n to the 8th. Letter C is 18, c to the 0. Anything to the 0 power is 1, but the 0 power is only on the c. So it's 18 times 1, which is 18. Part D, 4z to the negative 3rd. So the negative 3 is only on the z, so the 4 stays put. And z to the 3rd moves to the denominator. Letter E, I'm going to have to do some work here with the negative exponents. So I have 5 and b are okay, but the a needs to go to the denominator, so it's a positive 2. The 2 and the b to the 3rd are okay. The 3 was okay. The a squared goes to the denominator, and the b stays where it was. Now I'm going to multiply across the top, adding the exponents to get b to the 4th. Across the bottom, add the exponents to get a to the 4th. Then do the quotient rule with the b's. So I have 10 b to the 3rd over 3 a to the 4th. How do I know I'm done? Because my numbers don't reduce anymore. There is only one b left to the 3rd power and only one a left. to the 4th power. Section 5.5, dividing a polynomial by a monomial. So a polynomial, I'm just going to throw up some letters here, A, B, C, D, divided by a monomial E. You can split this fraction then what you would do is simplify each fraction. So that's exactly what I'm going to do. 12y to the 3rd over 4y plus 16y squared over 4y. Simplify each of those. 12 over 4 is 3, y squared plus 4y. Letter B is the same thing. 9x squared y squared, 3x squared y squared, and so on. Then simplify each of those fractions. So I have 3, the x's and the y's cancel. And I have 9, the x's cancel, but the y is actually left 1 y in the denominator. And then the 10 and the 3 don't simplify. The y's cancel, but the x is left 1 in the denominator.